Hello, everyone. I've had some folks asking me about the worst case and best case scenario questions that you've got from day 5 and 6, or day 5 and 6. So I'm going to take a moment and talk about those and show you how you can use the sample problem that you were given to help you answer those. On worst case scenario, the first question wants us to write a function that would tell us how many patients would have the ZLI virus at each day if there was no treatment. This is worst case scenario with no treatment at all. So the basic form of an exponential function is y equals a times b to the x. A and b are values that we'll fill in, and then the x and y are variables. A is the y-intercept of the function. It's the value of the function when x is equal to 0. Sometimes we call that the initial value at the very beginning point where we're taking data collection at day 0 or time equals 0. How much of the, what is the value of y? What is the value of what we're tracking on that day or at that moment? Then for our exponential functions, what we're doing is every time x increases, then the value of y is actually being multiplied. So as we add to x, we're multiplying by y. We call that the add multiply property of exponential functions. So the value b here is the value that we're multiplying by each time. And then the value x is just how many times we've multiplied times b. That's the exponential part of the function. So this is the number of times that we have actually had b multiplying the initial value. All right, so we want to say for this problem, what is going to be well, here I'm looking at the sample problem that was left on Canvas for you, done by Mrs. Rose and Mr. Walters or Mr. Waters. And so let's take a look at what they did on their worst case scenario. All right, so going to the worst case scenario problem, they have written this function for us. So here we've got the y equals a times b to the x. So to write this function, I just need to know what is that initial value and what is the constant growth or decay factor. Well, for our situation, that constant factor, that's the number of infected people at day 0 when all of this started. And the problem tells us that that's 12. Then we want to know, okay, well, what is it that we're multiplying by? Well, we know that each day there are 4 times the number of zombies that there were the day before, because each zombie creates 4 new zombies and then dies. So there's, for each zombie on one day, there are 4 zombies the next day. So our multiplier is 4. So that's the value of a and b. So now we just say y is equal to 12 times 4 to the x power. And just to make this fit the problem a little more, instead of writing x, we'll just say d, because x is just the number of days, and y is what we're tracking. That's the number of zombies. So we could just say z equals 12 times 4 to the d. Okay, well then the second question that you're asked on worst case scenario says, okay, well then using this function, how long until the entire city of New York, if nothing is treated, how long until the entire city is overrun with the virus? And there's 8,491,079 people in New York. Well, we have that problem, that same exact problem work for us for the city of Lexington, where there's 321,959 people. Basically, we're saying, when will this number of zombies be equal to 321,959. So we could have set 321,959 equal to 12 times 4 to the d power and solve for d. And that's been done here. We divided both sides by 12, and then we took the base 4 log of both sides to get that d out of that exponent, and we ended up with d being the base 4 log of 26,829.9, and we punched it in a calculator in 7.35. All right, so on your problem, you're going to be doing basically the same thing, except you're using the population of New York City, not the population of Lexington, and determining how many days until the entire city of New York would be overrun with the virus if no other measures were taken, if there was no treatment. That's the worst case scenario.